Hello, this is section 6.3 and 6.4, Factoring Special Products. Part 1, Factoring Special Forms. Recall from previous sections that there are a handful of special products. In fact, those same relations are also special factoring formats if used in reverse. If you can't remember one of these special formulas, AC factorization will always work in their place as per the note in the previous section. So we're going to factor these completely. So here I have two terms. The special technique to use to factor it only works if both of them are a perfect square. Well, 3x squared is 9x squared, and 11 squared is 121. So we have a difference of squares. So that means this will factor into 3x minus 11 times 3x plus 11. Part B. Well, 81x squared is the same thing as 9x squared, and 1 squared is 1. So we again have a difference of squares here. So we will get 9x minus 1 and 9x plus 1. Part C, 3x squared minus 75. Well, 3 is not a perfect square, and neither is 75, so maybe we cannot factor this. But don't forget, the first step of factoring is to always factor out the GCF, which is 3. Then we get x squared minus 25, in which case x squared equals x squared, and 5 squared equals 25. So then this becomes 3x minus 5, x plus 5. Now 4x squared minus 12x plus 9 can be factored as 2x minus 3 and 2x plus 3. Now this one isn't as easy to remember, but this is because 2x squared is 4x squared, 3 squared is 9, and then if I take 2x times 3 and double it, that gives me the 12x. But in order to get the negative 12x, both of them must be negative. And I already see I wrote something wrong here. They should both be 2x minus 3. There we go. So in summary, perfect square trinomials will factor as a plus b squared. Difference of squares will factor as a minus b times a plus b. And as a side note, the sum of squares a squared plus b squared is not factorable. If there is no GCF. So of course, whenever you have any number of terms, it's possible to have a GCF. But if there are no GCFs, then the sum of squares is not factorable. Sum and difference of cubes. Well, a cubed plus b cubed will factor as a plus b times a squared minus ab plus b squared. And a cubed minus b cubed will factor as a minus b times a squared plus ab plus b squared. So in general, you'll have a squared, a times b squared. And then the first sign will match the sign from the binomial. The second sign will be the opposite of that sign, and the third sign is always positive. That's how I have those two formulas down in my brain. Example 2, factor the following cubic polynomial expressions. Well, x cubed is x cubed, and 3 cubed is 27. So this is a sum of cubes, so it'll factor as x plus 3, x squared plus 3x plus 9, because 9 is 3 squared. Part B. Well, 27u cubed is 3u cubed, and 5x cubed is 125x cubed. So we have a difference of cubes here, so it'll be 3u minus 5x, 9u squared minus 15ux plus 25x squared. Again, I squared the 3u to get the 9u squared. I squared the 5x to get the 25x squared. And then I took 3u times 5x to get the negative 15ux. And again, I keep doing sign errors tonight. I am sorry. That should be a plus sign there. And this one over here should be a minus sign. So let me recap to remedy my sign errors. Part A factors into x plus 3 times x squared minus 3x plus 9. And part B factors into 3u minus 5x times 9u squared plus 15ux plus 25x squared. Part 2, general guidelines for factoring polynomials. We will often want to use more than one of the above strategies to factor a quadratic expression. The following will help us progress through our methods in the most efficient manner. Step 1, factor out any common factors. Use the GCF. Step 2, factor trinomials using the AC method or a special formula. Step 3, factors polynomials with 4 or more terms by grouping. And step 4 is repeat steps 1 through 3 with your remaining factors. So example 3, factor the following expressions completely. So part A is 7x cubed minus 21x squared minus 70x. So first step, factor out the GCF, which is 7x. Next, see if you can factor anything further. 7x is as factored as it can go. The x squared minus 3x minus 10 is a quadratic trinomial with a leading coefficient of 1. So I'm going to try to factor it by guess and check. What times what is x squared? X and x. What times what is 10? 2 and 5. One of them has to be negative, and since the middle term is negative, the larger one has to be negative. So we get 7x times x plus 2 times x minus 5, and part A is fully factored. Part B, 24y squared minus 150. First step, take out the GCF, which is 6. And we get 6 times 4y squared minus 25. Now, because I have two terms, is this a difference of squares? Yes, because 2y squared is 4y squared. 5 squared is 25. So this will factor as 6, 2y minus 5, 2y plus 5. Part C, 12x cubed y squared plus 75x y squared. First thing I notice is that I can factor out a 3, xy squared, and we'll get 4x squared plus 25. Well, 4 and 25 are both perfect squares, but because this is a sum of squares, it cannot factor any further. So this is our final answer, 3xy squared times 4x squared plus 25. And finally, part D, 40x squared y plus 44xy minus 24y. First, take out the GCF, which is 4y. Then we get 10x squared plus 11x minus 6. Now I have a quadratic trinomial, but the leading coefficient is 10. So instead of guess and check, I am going to use the asterisk method. A times C is negative 60. B is 11. ax is 10x, ax is 10x. Now, what two numbers multiply to negative 60 but add up to 11? 15 and negative 4. Now reduce. We get 2x over 3, and we get 5x over negative 2. So that means this factors as 4y times 2x plus 3 times 5x minus 2. And that is it for the section 6.3 and 6.4 notes.